In this video, you will learn about some of the equipment and methods that are used in construction site dewatering. Construction dewatering operations are common on most construction projects during the site development and foundation stages. This work can range from the simple removal of occasional ponded rainwater to the complete lowering of the groundwater table under portions of the site. Construction managers must consider a number of factors when planning dewatering operations. For example, will the soil give up the water? Not all soils can be dewatered. Granular soils are fairly easy to dewater, but other types of soils may not dewater at all, and the excavation work may then require the use of watertight sheet piling systems. Dewatering methods and equipment selection depend on how much water will be encountered and how fast the groundwater will recharge as the water is removed. Surrounding residents and structures must also be considered in terms of the pump operation noise and the potential for structural settlement when a high groundwater table is drawn down. Huge issues can be: 1, where to discharge the water, and 2, what to do if the water is turbid. At this point, you should just know that there are methods to remove suspended solids in water to meet discharge requirements. Additional things to consider: will backup pumps be necessary? What would happen if the pumping equipment would stop due to a mechanical problem? Is the risk of the excavated area flooding sufficient to justify the cost of standby or backup pumps? Additionally, working in a union environment, realize that the operating engineers will usually claim and require that an operating engineer be assigned to gas or diesel pumps. Electric pumps, on the other hand, do not require manning by any union personnel. And lastly, know that there are specialized dewatering contractors available across the country. Let's talk about methods and equipment then. At a high level, there are 2 methods used to dewater soils: surface pumping and pre-drainage. Let's take a look then at surface pumping first. Surface pumping is open pumping from sumps or ditches or ponds during the process of excavation. Let's look at an example here. And this is a large pond that was excavated in a residential development near Jacksonville, Florida. The pond's about 15 feet deep, and a single hydraulic pump was used to dewater this work. We can see the pump over here. The process used to excavate ponds like we just saw is called rim ditching, and let me show you how that works. You'll see again we use hydraulic pumps a lot for this type of operation. We'll get back to them in a minute. Rim ditching is simply the process of digging a ditch around the perimeter of the pond and placing the pump head itself, into the lowest portion of that rim ditch. And as this pump is then activated, water will flow by gravity, and it'll flow out of the bank and it'll flow into this ditch. It'll be collected and then removed by the pump. And as work progresses, then a series of rim ditches are excavated almost continuously till you reach the desired bottom elevation. And this then depicts our starting water level, and this is what the water would look like when we reached our final grade. In terms of equipment, there are a lot of different types of pumps available, but we just mentioned hydraulics, so let's take a look at that one specifically. Hydraulic pumps are very versatile and come in sizes from about 6-inch up to 30 inches in diameter, and the larger pumps can pump a tremendous amount of water. With a hydraulic pump, the pump head itself sits in a sump, as we see here. This was a foundation project in Florida. The pump gets its name because it is powered by a remote power unit hydraulically. The hydraulic fluid then under pressure flows through these lines. It turns the pump head, and the pump then intakes the water and pushes the water out through the discharge line. And in the right side picture here, we can get a little better look at what a typical diesel power unit is. Okay, so that's a quick look at this open or surface pumping. Let's move on and talk about pre-drainage. And the pre-drainage dewatering method is essentially removing the groundwater from either outside or below the limits of the work prior to excavation. There are three main methods that are used for pre-drainage, and let's take a look at the first one of these called well points. Here we see a structure being built in a dewatered excavation. The red units are the well point vacuum pumps, and the white lines obviously are the well point vacuum lines, and we can see the individual well points installed here. Let's understand how a well point system works a little better here. Probably the easiest way to think about well points is that they're a vacuum system and they operate essentially like a soda straw does. The points are installed fairly close together depending on the conditions. 2, 3, 4 feet apart is not uncommon. And the points then, these giant straws, are typically 2-inch diameter PVC pipe, and they're perforated in the bottom 18 inches or so. And they're connected then with a flexible connection to a vacuum line, or a vacuum manifold as it's called. And the vacuum manifold then is connected to a vacuum pump. The pump then creates negative air pressure, and this vacuum or negative pressure then will draw water out of the soil, and it will draw it into the well point, and then it will vertically lift the water up the well point through the flexible connection into the manifold line and then out through the vacuum pump discharge itself. Because this flow of water, particularly the lift, is from a pressure differential, well points only have an effective depth of about 15 to 20 feet. But that's not a major problem, because if we have to excavate deeper, we can stage the well points as you see here every 10, 15, or 20 feet, and it's possible to stage these 5, 6 times, and I've seen well point excavations deeper than 50 feet. Here we see a crew working in the Hilton Head area, and they're installing a well point system at the bottom of about a 15-foot excavation where the water table is. Here's the vacuum line, here's the flexible connection, and here's a well point that's already been installed. Our next system is called the deep well system, and let's take a quick look at that. Deep wells are essentially wells or casings, metal or PVC perforated pipe that have been installed by drilling, typically 30, 40, maybe as deep as 60 feet, just depending. And in each of these well pipes or casings then is installed a submersible electric pump, and they come in various sizes. And here's kind of how that system operates. It's very similar in concept to the well point, but the exception is that the water flows by gravity to the perforated section and then is pushed upward by the pump into the discharge line. Our last system is the horizontal underdrain system, and this system was initially developed for dewatering farm fields. The horizontal drain consists of a perforated 4-inch piece of PVC pipe, and the pipe is wrapped with a filter fabric sock, so it's called a sock drain. This is a very inexpensive pipe, and it's installed by a special trenching machine, typically to depths of 20 to 22 feet. An unperforated section is connected to the end after it's installed. This is connected then to a vacuum pump normally, and the water then, just like a well point, is withdrawn by vacuum and discharged. When the work is done, the pipe, because it's low cost, is simply abandoned and left in place.